This talk discusses kind of the tip of the spear HLS version. It's a draft, link below. So if you are interested in which version of the spec I'm talking about, this is the version. Who's my audience? I assume some familiar with regular HLS, regular non-low latency HLS, codec structure, like what's an iframe, HTTP, people who like long, boring text slides, and fans of Public Enemy who might recognize the name of my talk. We're going to talk in particular about, scaling an LL-HLS origin farm is kind of a well understood, thing. Your vendor will be able to tell you if you have this many players, you need this many origins with the CDN in the middle and stuff. And so really, how does LL-HLS change that? Because as we know, we've broken the video segments up into smaller pieces. And so there's a lot more kind of back and forth traffic between the player and the origin. And there's several other things in the spec besides that really affect origin scaling. So I've gone through the very latest version, HLS version 10, and I'd like to call out kind of all of the areas in the specification that have changed since previous versions of the HLS that would change how you would scale your origin. And so this is not specific to Wowza. This is to any LL-HLS server product. So these are the topics that I'll be going over. So like I said, one change is obvious. You used to fetch one media segment and play it out. Now you fetch individual parts of it. So there's, obviously the number of transactions are going to go up by n. You can use byte range requests for the parts that could refer into kind of the master segment. Otherwise, you'll need twice the CDN. You'll need all the CDN to store the individual parts and all the CDN to store the entire segment, although the individual parts will be fairly short-lived. Audio and video and WebVTT and closed captions and other things can have different partial segment durations within the same asset. I'm not sure of a use case for this, and so if anybody can think of one when we get to the Q&A, I'd love to discuss that. And finally, players can now adapt between different variant playlists and different quality levels on part boundaries if those parts contain iframes. This will obviously affect your CDN bandwidth because typically an iframe is the largest thing in a video segment, and if you've got more iframes within it, you're not going to get as much coding gain. On the other hand, you could adapt between bit rates faster. So it's a classic engineering trade-off. So let's take a quick look at a M3U8 variant playlist, just one entry for one segment that shows the parts and then the entire segment. Here, following Apple recommendations, we've got a 6-second video segment, and then we have 6 1-second partial fragments, and every other one contains an iframe. So you could adapt potentially between bit rates every 2 seconds in this example. And the way you can tell they have an iframe is they've got this independent equals yes tag on the end. I don't know, maybe I'm the only one, but I think it's fantastically funny that I'm sitting here in 2020 and we are looking at what's essentially a Winamp media playlist containing MP4 files that's based on the Amiga interchange file format specification. So, the more things change, the more they stay the same. So that's some of the joy I get in this industry is little moments of irony like that. Okay, so that's kind of the obvious change affecting scaling, but let's talk about some of the others. Previous versions of the LL-HLS draft allowed kind of a wide number of playlists to be served. In the current version, that's cut down to 3. So if you're sizing, the traffic you're going to get, the amount of storage you need in your CDN. It's going to be, for manifests, about 3 times as much as it was prior. You're going to have your regular playlist that gets served up. By the way, the spec says that gzipping the playlists and serving them up that way is mandatory. They do want to minimize the transfer time to make low latency work well. And then in the new versions of the spec, you can pass query parameters to the origin. They call them directives in the spec. And in particular here, there's 2 called HLS. There's one called HLS skip, and it can have 1 of 2 values, yes and V2, which is kind of an interesting set of choices, I think. So what the HLS skip directive does, we'll look at it here on the next slide, is for a long playlist, you know, in the low latency use case where you have very short parts, you want to be able to update that playlist very quickly. So you can serve up essentially truncated versions of the playlist that only show the segments that are near the live edge, and players can request that. Now, if they get lost and they fall off the top of that truncated playlist, of course, they can request the playlist without the HLS skip directive, get the whole thing, reorient themselves in the right, you know, find the right media sequence number and start playing again. One interesting thing I'd like to point out is as CDN edge compute becomes a more standard offering in the industry, HLS skip could entirely be implemented with CDN edge compute, and then that would take no trip to the origin, and I think it would scale very nicely. So here's an example. As you can see, I was watching my favorite movie, Big Buck Bunny. Never get tired of that one. So if we look here at the very beginning, I just curl the stream, the M3U8, to get the playlist. And in the playlist, you see a couple things. We're at version 6, which is the highest version, or actually the lowest HLS version that supports all the tags that are in this media playlist. And then in particular here in the EXTX server control tag, we have the can skip and tell attribute that says you can request the playlist and just get kind of the bottom 36 seconds here and not get the top, should you decide to. And so here I have passed the directive HLS skip equals yes, and we get back a playlist, which is version 9, which is in the spec. It says if you say HLS skip equals yes, the player has to respond with version 9. And you can see that, for instance, we have skipped the top 6 segments in this playlist. They were not delivered. The 2 values of HLS skip, yes and V2, if you say yes, what it does is it essentially windows off that top part of the segments. If you say V2, it windows off not only the segments, but it also takes any SCUDdy35 tags that may be in that period of time and also windows them off. So it kind of feels like, you know, they implemented it, they spec'd it, and then they're like, oh my goodness, what about SCUDdy35? Well, we'll add a V2 parameter, so you can also truncate those if you desire. Here's one that is kind of non-obvious and was kind of hard to dig out of the spec. I didn't notice it at first. But, you know, fundamentally, barring the new, you know, blocking playlist reload and things like that, HLS players will pull to get a new playlist over and over again. And at the top of a HLS media playlist, there is a tag called ext target duration that says all the segments in this playlist are going to be this long or shorter in units of seconds. Or it's rounded to the nearest second now. The semantics of that has actually changed over time. So in previous versions of the HLS spec, players would poll at EXTX target duration intervals. So if it was 6, every 6 seconds. And then if they polled at 6 seconds and they didn't see any new segments in windows, they would cut that in half and try again several times before giving up. And different players have different retry strategies, but typical would be to try to move to a different media playlist, a different variant, and see whether you could get updates there. In the new HLS spec, the new draft, the player pulls at the duration of the last media segment with retries every half target duration. And so this effectively lowers the latency for some low latency use cases and also for non-low latency players, and I'll discuss this with an example in the next slide. But it does cause more frequent manifest requests in general. So this does affect your scaling, and you'll have to calculate with your segment lengths and your target duration what the impact would be. There have been a couple of use cases that I've seen in past lives where you set the EXT target duration to be fairly long compared to your average segment size. So one example that I've seen in the past is where the video coming into the packager had some kind of, like chop here marker in it, like a CableLabs EBP or something like that. And then the video was moved, say, MPEG-2 TS over UDP protocol with no error correction, right? So not like SRT or something cool like that, just straight, UDP multicast. Well, what can happen is you could happen to lose the UDP packet that contained the chop here marker. And so, if you had a 2-second segment length, all of a sudden some segments every now and then, not all the time, will be 4 seconds. Well, you can't change the target duration in an HLS media playlist. The spec actually says you can't do that, like specifically calls it out. So you can't have it be 2 sometimes and then update the playlist and the player says, oh, now it's 4. You have to set it to 4 from the beginning. And so the effect of that, is players will tend to play back farther in the playlist because they'll get less frequent updates at the live edge, and when they do, they'll get several fragments at the live edge, usually. I mean, this is a statistical thing. I've also seen cases where there have been a cloud DVR recording system where for reasons of scalability, they didn't store the individual segments individually, they stored them as a group. And then, because they wouldn't update the playlist once every segment length, they would update it once every group of segment lengths, they would set the target duration longer in order to slow down the player requests and not have the player play off the end of the live edge, which is bad. You get a rebuffer. But you can't do that with this version of the HLS spec. So that may be a design issue for you. And like I said, in general, you'll see for players that poll and aren't doing blocking reload, you'll see more polls as a result of this with certain use cases. Speaking of blocking playlist reload, so the server can say, don't poll me for an updated playlist with new media segments in it. Just make a request for it, and you can block. And when the server has a new playlist with new segments or new partial segments, it will provide an update to the player. And the player can say, I want to see this media sequence number in window and this part of that media sequence number in window. And when that happens, send it to me. So that effectively decimates the amount of requests that a player has to make in order to get the playlist update. That's very nice. That helps you scale. There is a limit on it. If you cannot get to that media sequence number and that part within 3 target durations, you should give up and return a 503. So there's kind of a limit as to how much you can decimate player requests. The player can't ask for things that are really far in the future. If you think about it, that would kind of be a denial of service issue because you're using up a resource. You're server side, you're using up a connection. So here's an example of blocking playlist reload. Again, with my favorite movie, Big Buck Bunny. Here in my first request, And I've deleted a bunch of stuff because these are long, noisy HLS playlists. We have media sequence number 7695. And I said, okay, wait until 7966 is in window. And as you can see here, this one, it's a 6-second segment. We're 2 seconds into it. So, after about 4 seconds, all of a sudden I get a response from curl back with the new playlist. And indeed, 7966 is just in window, and the first fragment, or the first part of that segment, rather, is in window. So that's kind of cool. That will really help LL-HLS scale if done correctly. So the next thing is you can do kind of a similar thing to doing a blocking load of playlists with segments. And so the spec allows servers to say, hey, I have the capability of using a tag called EXTX preload hint. And this allows players to make blocking requests for segment parts and initialization segments. And again, this is intended to reduce load due to polling. I would like to point out, though, in many cases, when you get a segment part, you're probably going to have to pull a manifest anyway afterwards. So it's not the win that you might think it would be. And the reason for this is it says it may have a different discontinuity sequence number, media initialization segment, or encryption configuration. So it could turn out that there was a discontinuity before that part, or a crypto key rotated, or something like that, and you're going to have to pull the manifest and find that out. Oh, I got a new crypto key, I probably have to go get a new PSSH box, that kind of thing. So there may be some additional network traffic that you have to do, even though you've done kind of a blocking wait for this segment part. Finally, if you're currently terminating your client connections, which are persistent for these blocking loads, with a CDN, then you need to make sure that the CDN supports coalescing duplicate requests, so you don't get hit over and over again. Otherwise, you're going to have to make sure that you have enough packagers to actually handle that many concurrent TCP connections, which can be a problem. Again, it's a server-side, finite server-side resource. Finally, another thing that has come up is HTTP2. And, at one time, Apple had HTTP2 push in the spec as a way for players to say, I want this, partial segment, give it to me when it's available. People just absolutely wigged out, especially the CDN people. I'm not a CDN people, so I cannot speak to why, but I assume they had a good reason. So Apple removed the HTTP2 push requirement from the spec, but they did not remove the HTTP2 requirement from the spec. The spec actually requires, with must language, that HTTP delivered playlists and segments are HTTP2 all the way from the origin to the player. And they have some other recommendations, both musts and shoulds, around TCP features that you should support. Also, stuff around TLS. They want zero round trip time TLS support. And in fact, at Wowza, we've tried it, and if you try terminating, say, HTTP2 at an Nginx and then do HTTP1 back to the origin, you do see a noticeable increase in latency. It's a thing. So it can very negatively impact your scaling. So I would say that the spec requires very careful attention to detail around the network path all the way between the player and the origin through the CDN, the whole thing. You have to be very careful about how you implement TLS and how you implement TCP, more so than with previous versions of the spec. So in summary, what does all this mean? I mean, I outlined a number of factors where you can say, okay, if I could support 300 connections with one of these servers, now I can only maybe support 100 or whatever, right? You can do the computations for the various effects, but that means that you have to know your player population. Your origin load is going to strongly depend upon your player behavior. So you're going to have to really understand, I've got X% of my players that know how to do blocking playlist reload, and other ones don't. And these ones are low latency, and these ones are not low latency. And the low latency ones will be fetching the segment parts individually, whereas the non-low latency will be fetching entire media segments at a time. So once you have a good idea of your player demographics, you can calculate the change in load with each of the factors that I've gone through, and apply it, and basically modify your calculation to say how many origin servers do I need to support this many players. And of course, these player demographics will change over time. Apple will release new iOS versions, more people will upgrade. Different players like Theo Player and HLS.js that support low latency or have varying degrees of support for it will increase their support over time, and you'll see them taking advantage of features that perhaps they didn't in the past. And so you're going to have to keep track of that. Finally, I wanted to point out a little HLS puzzle that I came across while playing with LL-HLS for this paper. So the EXTX version tag in your variant playlist, it should basically be the one that supports all the tags in your playlist. And so, like, if you're doing a low latency configuration with a recent Wowza streaming engine, that's going to be EXTX version 6. But then say you request a playlist with the HLS skip directive on the end. What happens then? Well, the spec says if you've got HLS skip equals yes, the reply must have EXTX version 9, and if it's got HLS skip equals v2, it must reply with HLS version equals 10. But it turns out that there's rules in the HLS spec about the things that a player can change in a playlist between player loads, and the version isn't one of them. So a little bit of a contradiction there. I might try to report this to Apple, but I think in this section, 6.2 kind of general server responsibilities in the HLS spec, you should expect, if you're a player implementer, you should expect to see the EXTX version in the reply from the server to change in those two particular cases, even though the spec appears to disallow it in one place and require it in another. Thank you. Any questions?
That's great. I got a question. I have a question. What would be the reason to ever do skip yes? Why not just always do skip v2? Is it completely backwards compatible with skip yes?
Because they basically released a version of the spec into the wilds that had skip yes, and the semantics of that just said, oh, the segments are removed off the top of the playlist, the ones farthest away from the live edge. And I assumed somebody thought, oh, what about SCUDdy35 tags? There can be a lot of those. Like if you've worked in DAI-enabled IP stack, there can be a giant laundry list of those. And the goal here is really to provide the minimal manifest update to a player so it can quickly acquire it, find the next segment part, and pull it in a very fast manner. And so what good are all those old SCUDdy35 tags in the past doing anyway? They were interleaved with segments that are not in this version of the playlist. And so they added V2. So I assume it's just because that version of the spec escaped into the wild and perhaps people implemented against it and expected those semantics.
Okay.
Hopefully not a V3 and a 4.
Hopefully not a V3.
I just love the options of yes in all caps and V2
I know, right?
lowercase v. That's just like my favorite random little.
Oh, sorry. It's hard. I didn't mean to cut you off.
No, go ahead.
I'll be interested to see how this works with SCSI 35, especially when SCSI 35 gives you a predetermined time of an ad, right? I'm trying to put it in my head. How will that work with inserting an ad that is, let's say, 20 minutes from now, as per se? Because in SCSI 35, you could have a list of ads. And it's not really a question. I'm just trying to wrap my head around it, really.
Yeah. I'm trying to get to the spec again, and unfortunately I had Chrome in full screen mode. Okay, so if we're here in the spec and we search for, what is it, EXTX date range.
There we go. Yeah, that would make sense.
So let's see, I think there's an example here of embedding SCSI 35 in an EXTX date range near the end of the spec. Search. Oh, good Lord. There we go.
There it is.
So here's some examples of the EXTX date range containing SCSI 35 tags. And so here, to answer your question, maybe Doug, there's a start date attribute and a planned duration, which I would have called it duration maybe. Yeah.
Perfect. Yep. Cool. Any other questions?
Let's see. Okay. Yeah, some comments in the Twitch.
Yes.
But
let's see.
So prior to version 9 and 10, will we always see version 6? The bit about playlist refresh being based on target duration or last segment duration was interesting. Is there a version signal for that?
Yes, there is. I don't remember what it is offhand. I have to go back and look at all the various draft versions of the spec to try to recreate that. They do have a kind of what's changed in this version thing, and so you can walk through the different spec drafts and look at that. But certainly the most recent draft, the client polling behavior has changed. Let's see, there was a second question that prior to versions 9 and 10, will we always see version 6? No, there are some cases in the spec where you might have different versions. There is a section, what is it, section 7, here. Let me share my screen again.
No, you have it memorized.
Yeah, I've read this a few times. Unfortunately, it's a short spec. It's not like, the 12,000 page dash spec. It's just 80 pages or so, right? So here you can see if you have, the following things in your playlist, then you have to be version 7. And then, here, if you have variable substitution, it's going to be version 8. And so you can see that there's different incremental different versions where they bump the protocol version number. In general, these signal an incompatibility, so they want you to specify the lowest version that you can. And so different products will put different tags in, and so they'll in general have different EXTX versions. But if you do use these skip features, you are going to be seeing 9 or 10 in the responses when you request playlists that have EXTX skip tags.
Yep. And Rob also just wants he wants you to know that SCSI's horrible. And part of the spec says you need to duplicate date range IDs to match the out and in ranges, which crashes Safari. So
I have worked with DAI enabled stacks before, and I'm fully aware that SCSI 35 is kind of horrible.
What that leads to another question of how's the
I got
player
2
support
stars.
generally?
Pardon me?
How's
Broadly
the players,
speaking?
Yeah, broadly speaking, how's the player support? Is it still way new and kind of an
It's
alpha
way
for all the
new.
players?
It's way new. If I could comment, just because I did a webinar on it yesterday. Days blur here. We've been working with TheoPlayer on it because they've been working to stay ahead of the curve there. They're probably one of those player vendors that has stayed closest to it. I know JW is working on it. HLS.js is included in that effort. I know that Video.js has hinted at working at it on it, but I haven't reached out lately. But I haven't heard anyone else say they're working on it yet either. And I think that the reality is, you're going to get a lot of people that will quickly jump at this, and then you'll have to, vendors will have to jump on this,
Right.
and more and more. And the delivery side will come easy. What won't come easy is things like we're talking about here with, advertising, and timed metadata is another one we talked about. And there's other, there's all kinds of things. Captions is going to be another tricky one.
Encryption too.
Yeah.
Especially, yeah.
Mm-hmm. Yep. The interesting one with the captions that, when we did our thing with Theo the other day, was they mentioned, if you've got short segments and you've got captions, partial segments that are really short, and somebody does something, speaks something that's not, spans across those boundaries, how do you know? And it's out of band stuff, right? It's not in band. How do you display it and let it disappear real quick? Do you display it and display it and display it? And how do you know when to get rid of it? And, there's this timing issue, right? So
interesting.
Yeah, so lots of things need.
It appears that the spec allows a key rotation between segment parts. And I think it would be a miracle if a player handled that.
We talked about the timing of that. Like, can it all happen fast enough, right? And then you'll get a player stall or, some sort of other issue, right? So
yeah, you can have a new media initialization segment for every single part. That's pretty interesting.
Right.
And
I mean,
iOS 14 came out. iOS 14 has support for this and in its player engine. So
that's true. Yeah, you've got the native stuff, and then others are working. Eventually Android specific devices and OTT devices will play catch up. I think we've had asks for this on Roku, for example, already. We have no idea where Roku stands on this at the moment. So, I was going to tell you though. I forget, but I mean, time will tell. But people are working on it. Eventually, I know. I was going to say. I mean, Apple's done some good intro conversations, like on SSAI and other pieces, and then in other ways they haven't really thought about any of it, or at least said anything. And it's going to be up to the kind of ecosystem to figure it out, I think, or see if they can figure it out before Apple has to jump in, or if they jump in.
Cool. Well, great. Thanks, Ben. Thanks, Jamie. Thanks, Wowza, for it. It was great.